Hello students. So today we are going to discuss about probability. This is one of the topic in forecasting section of Section B in CMA Part 1. Okay. So what is probability? Probability of an event that is happening is the chance that it will happen. Or an example we can say, on a cloudy day, we may say that there is 70% chance that it will rain. So probability is what actually this chance is. So a chance of happening something, that is what actually probability. This is also means that when you say 70% chance is that there will be raining today, you are also telling that 30% chance is that it won't be raining today. So probability means a chance of something that may or may not happen. And normally probability is expressed as a value between 0 and 1 when we talking about decimal values, and it can be converted to percentage from 0% to 100%. So 0 or 0% means a probability of 0 or 0% means that there is no chance that that event is going to occur. But if the percentage is 100 or the value is 1, that would mean that that event is absolutely certain. It is 100% it is going to occur. So the value of probability is actually going to be between 0 and 1, or in percentage term it is going to be between 0% and 100%. So if an event that is going to happen for 100%, then the value of the probability is 1, and if it is impossible to happen, the value is 0, and any value in between, for example, if it is 0.5, that means that there is 50% chance that the event may occur. At the same time, 50% chance that event may not occur. So the probability value is always between 0 and 1. The two requirements of probability. The probability values assigned to each of the probable outcome must be between 0 and 1. This we discussed already. The values of probability, it has to come between 0 and 1. And as we said, 0 means the event will not occur. 1 means it is certain that the event is going to occur. And the probabilities of all assigned values, it has to total to 1. That's another requirement of probability. For example, here, when we say 70% chance is that there will be a rain today, that means 30% chance is that it will not be raining today. So if you add this 70% and 30%, it has to total to 100%. Or we can say the probabilities of an event and its complementary event. What is complementary event? A complementary event is that represents all outcomes that not covered by the original event. Or we can say when it rains today, the complementary event is it does not rain today. So if you add the probabilities of it is going to rain today and the probabilities of it is not going to rain today, we should get 100%. Okay, so these are the two rules of probabilities. Now we are going to apply this. Now we are going to apply these probabilities in making our business decisions, especially in Section B of CMA Part 1, when we are dealing with budgeting. We are going to use probabilities to find out some future value in terms of sales or in terms of cash flows and a lot of other things to find out what may happen in future. For that, we are going to use probability. Here we are talking about how you will calculate the probability. What's the formula for the probability? The probability formula is actually number of outcomes or number of favorable outcome divided by total number of possible outcomes. Here we have an example of rolling a die. If you roll a die, you may get 1, 2, 3, 4 or 5 or 6. When you roll a die, you may get any of these values, right? So these are the possible outcomes you can get by rolling a die. Now, what's the chance of getting the value 1 when you roll a die? It is, you will get value 1 out of 6 values, right? So there are total 6 values, possible outcomes are 6, and the chance of getting number 1 is going to be 16.6%, or we can say it is 1 by 6. Or we can say probability of event that you will get always odd numbers. All odd numbers come up. So the probability is going to be 3 is the chances of odd numbers and 6 is the total possible outcomes. So you may get 1, 3 or 5. So 3 values out of 6 values, that is going to be 50%. So this is how you will calculate the probability of an event. The number of favorable outcomes divided by total number of possible outcomes. So when we are making decisions in business, there will be situations where we have to find out the probabilities of 2 events occurring, or probabilities of 1 event out of 2 events occurring. Okay, for that we have to first understand what is an independent event and what is a mutually exclusive event. And an independent event means if the occurrence or non-occurrence of one event does not change the probability of the occurrence of the other event. Or we can say both events can occur at the same time. That is what we call it as independent events. For example, a company decides to open a new store in city A. This is one of the event. We call it as event A. And event B is the same company decides to open a new store in city B. That is event B. Okay, a company is deciding to open a store in the city A and open a new store in city B. So here, the decision to open the store in city A does not affect the decision to open store in city B. Especially when there is no budget constraint. They have enough capital to invest. So even though they open a branch in city A, still they can open a branch in city B. So these two events are not depending each other. These are independent events. But same example, if we take and we have limited budget, that means we can open only one store in any of the city. Then these events we call as mutually exclusive events. Why? In this case, both the events cannot occur at the same time. Either they will open a branch in city A or they will open a branch in city B. But they can't open two branches in both the cities as they don't have enough money. So this we will say this event is actually mutually exclusive event. If you choose city A, you will not be opening the branch in city B. Okay, so this we call it as mutually exclusive events. So we have to know this before we go into addition and multiplication rule of probabilities. So this is the rule of addition, or we call it as OR rule in probability. So what is that What does this mean? The rule of addition states that probability of two or more mutually exclusive events occurring is the sum of the probabilities of the individual events occurring. Or we can say you have an event, the probability of that event occurring is 40%, and you have an event B, the probability of happening that event is 30%, and the probability of event A or B happening is just addition of both these probabilities. This is what we call it as rule of addition or rule. You just add the probabilities of two events here. You can see a business example here. The probability of the sales refrigerators will be 5 million next year. And what's the percentage of probability? 30. And there is 50% probability that sale of refrigerator will be 7.5 million in the next year. Or we can say the probability that sales of refrigerators will be 5 million or 7.5 million next year is going to be addition of both the probabilities, or we can say 80% chance that the sale of refrigerators for the next year will be 5 million or 7.5 million. So this is what we call it as addition rule when events are mutually exclusive. But if the events are not mutually exclusive, that means both events can happen at the same time in some cases. In this case, rule of addition says that probability of either event happening is the sum of each event's probabilities minus the probability of both events happening simultaneously. Or what we have to do is, we have to take the probability of event A, we will add that to the probability of event B, then we will minus the probability of both events occurring simultaneously. So this is the rule of addition when two events are not mutually exclusive. Here you have the example. If the probability of event happening is 30% and the probability of event B happening is 50%, and the probability of both event happening at the same time is 15%, then the probability of either event A or B happening is 30 plus 50 minus 15%, or we can say it is 65% chance is there either A or B or both can happen. So this is AND rule or rule of multiplication. The multiplication rule states that probability of two independent events occurring together is equal to the product of their individual probabilities, or we call this as AND rule. Previously it was OR rule, any of the event happening. But here both the event happening, A and B happening, is just the product of two individual probabilities. Here you have the example. If you have two events, events A and B, and the probability of event A occurring is 40 or 0.4, and the probability of B occurring is 0.3. So the probability of events A and B occurring is simultaneously 0.4 multiplied with 0.3, or we can say 0.12, or we can say it is 12%. So there are 12% chance that probability of A and B can occur simultaneously. And rule of multiplication also we can use to calculate the conditional probability. What is conditional probability? Conditional probability of an event is based on the occurrence of a previous event. Or we can say, what's the probability of event B happening after the probability of event A is occurred. So how you will calculate the probability? Conditional probability is calculated by multiplying the probability of preceding event by the updated probability of the succeeding event. Okay, we can make it simple here. Suppose you have a bag containing 3 red balls and 2 green balls. You have a bag that is having 3 red balls and 2 green balls. If you want to find out the probability of drawing a red ball, and in the second row you get a green ball without replacement. That means you have 3 red balls, you will draw one of the red ball, then second time you will draw another ball and it has to be green. So what is the probability of drawing red ball first, then getting a green ball second? So probability of red is actually 3 out of 5, right? The chance of getting a red in the first instance is 3 out of 5. Now you remove one of the red. Now how many possible outcomes are there? Only 4. Out of 5, 1 is removed. That's what without replacement. You didn't replace the red. Now how many options are there for you? You have 4 options, and out of that you need to get green ball. So you have 2 chances of getting green ball out of 4 options. So the probability is 2 by 4. Or we can say it is, if you multiply this, it is 6 by 20. Or we can say probability of red and green. What is the probability of getting red and green? The probability of getting red is actually 3 out of 5, right? You have 5 balls and in that you have 3 balls. So that is like 60% chance is that you will get red when there are 5 balls. Now 1 ball you removed. How many balls left now? Only 4 balls. And from that you have to get a green ball. So what is the chance of getting a green ball out of this 4 ball? There are 2 chances out of 4 options, right? Or we can say 2 by 4 or 50%. So once you draw the red ball, the chance of getting green ball is 50%. So the probability of drawing a red ball first and getting a green ball second is 30%. So this is what we call it as conditional probability. So we can use this example. The probability of sales being 1 million in 1 year is 30%. So there is a chance of sales being 1 million in the year 1. If that is true, if the sales are 1 million in year 1, there is chance that 40% probability that sales will be 1.5 million in year 2. Again, the probability of getting 1 million sale in the year 1 is 30%, and if there is 1 million sale in year 1, there is chance that your sale is going to be 1.5 million in the year 2. So what's the probability of getting 1 million sale in the first year and 1.5 million sale in the second year? It is going to be the probability of both multiplied with each other. So 30 multiplied by 40, 30% multiplied by 40%. Or we can say there are 12% chances that your sale is going to be 1 million in the first year and 1.5 million in the second year. So this is what we call as conditional probability. The probability of happening an event given the first event is already occurred. Okay, now by having this knowledge, we are going to apply these probability techniques in making business decisions, especially in budgeting in Section B. So first we will create a probability distributions. Based on that, we will find out something called expected value. Okay, so we will see step by step. The formal definition of probability distribution is a table that links each outcome and its probability. So we can say first year sale is going to be 1 million. What's the chance of probability? 50%. Maybe it can be 2 million. What's the probability? 25%. Maybe it can be, 3 million. The probability is 10%. So this kind of a table that linking the outcome and its probability, this is what we call it as a probability distribution. So we will start creating a probability distribution based on a computer store that sells computers every day. And they have sold computers for 312 days. Out of that, there were 17 days they didn't sell any computers. And 23 days they sold one computer each. 29 days they sold 2 computers per day. Like that, you can see a table we have created. Okay, now what we will do, we will create a probability for these events being occurred. So we know that 17 days we are not selling anything. That means 17 days out of 312 days, or we can say 6% of the days we are selling 0 computers. Then 23 out of 312 we are selling 1 computer, or we can say 8% of the days we are selling 1 computer. So if you add all this together as per our rule of probability, it has to add up to 100% or 1. Okay, it is happening. So these are the probability of selling 0 computer is 6%, selling 5 computer is 15%, selling 10 computer is 3%. So now we have the events and we have the probability of each event. Using this, we can create a probability distribution, and this is what we call it as a probability distribution. So you are adding probability to a frequency distribution. Now, using this, we can calculate expected value. So now we want to know what's the average sale you are going to make on a particular day, considering all these events happened in the last 312 days. So what we can do is, we will take each output or each event, multiply that with the probability of each of the events. Selling 0 computer, probability is 0.06. Selling 5 computers, probability is 0.15. Then multiply number of sales with the probability of each sale happening, and you will get expected value. If you add all these together, you can get here 4.66. So what we have done here is, we are actually multiplying the outcome or a random variable with its probability. Or we are trying to find out the average of all possible outcomes, and we are considering the weight of each outcome as the probability of that outcome may occur. Or we can say this is a weighted average of the probabilities of each of the values. And we got 4.66 here. If you add all this together, you will get 4.66. And this is what the expected value of a particular day, or average of all possible values weighted based on their probabilities. That is going to be 4.66 per day. This is how we will calculate expected value. And this expected value we can use in different business decisions. We can take an example here. You have 2 projects here, project X and project Y. Okay, and you have here different scenarios. Maybe economy can be in deep recession, or it can be in mild recession. It can be in expansion, minor expansion and major expansion. And you can see in different scenarios what would be your cash flows for project X and Y. Now you have to decide which project I have to choose based on the expected value. So for this, what we have to know what's the chance of deep recession, or what's the probability of having mild recession. So if we add that, here we can see probability of deep recession is 5%, and project X is giving 200,000 cash flows. So for calculating the expected cash flow, so expected value of cash flow, we will multiply 5% with this 200,000 and we will get 10,000 here. Whereas project Y, we will multiply 5% with 100,000 and we are getting 5,000. Okay, so in this case, X is giving us more cash flows. Like that, you will multiply the each values with the probability of the scenarios that may happen, and you will add all that together and you will get X cash flow is going to be 312,500 and the cash flow from the Y project is going to be 325,000. Considering different scenarios that can happen in the economy and assigning a different possibility for each of those scenarios, we can find out, or we can budget our cash flow for the coming period. That is what we are doing here by employing expected value calculation here. Okay, so expected value is nothing but average of or weighted average of all the possible values, considering probabilities as the weight. Expected value of perfect information. Expected value of perfect information is like figuring out how much you would be willing to pay to know the future exactly before making a big decision. So it is actually helping you to understand how valuable it would be to have a perfect information compared to making a decision with only what you know. In calculation of expected value in the previous slide, we have done the calculation without having the perfect information. We did some assumptions, right? So if we know in advance the future state of economy, we could make much more informed choice between project X and Y in our example, right? If we know the future state of economy. So how much you are willing to pay to know the future state of economy? That's what expected value of the perfect information. We will see how this can be calculated. The expected value of perfect information is calculated by considering two things. One is expected value with perfect information and expected value without perfect information. The difference between these two is what we call it as expected value of perfect information. So expected value without perfect information we already calculated. That's what actually expected value we calculated in the previous slide. We don't have perfect information. But what is expected value with perfect information? That is the weighted average of the best decision that can be made under each possible state. What are the best decisions you can make under each possible state? Again, weighted according to probability of each state occurring. Okay, we'll go and see the example. Same example of cash flow. If we know economy is going to be in deep recession, probability is 5%, we will choose cash flow X here, right? Because this is the highest value now compared to Y. In this case also we will choose X. In this case we can choose either X or Y because both are giving you 150,000. When it is in minor expansion, project Y is going to give you better cash flow. When it is major expansion also, project Y is going to give you better cash flow. So if you add all these highlighted values, you will get a value of 335,000. This is what actually expected value with perfect information. So when you have perfect information, you will choose or you will make the best decision, right? And you will weight all these values based on the probability of the state of economic condition. And you got 335,000. And the calculation of expected value of the perfect information, as we said, it is expected value with perfect information and expected value without perfect information. The difference is 10,000. This is for project Y. We are considering the cash flow from the project Y. Cash flow from the project X is 312,500. So the expected value of the perfect information project X is going to be 22,500. So just imagine you have to pay $30,000 to get this expected or to get this perfect information. That means the amount what you are paying is going to be worthless, because even though you have perfect information, the maximum benefit you are going to get is going to be 22,500, and you are paying 30,000 to get this perfect information. Okay, so this is how you will calculate the expected value of the perfect information. And this is the last topic in this. What are the benefits and limitations of expected value? Expected value techniques helps an organization to determine average outcome of an event when faced with uncertainties. So expected value is actually helping you to find out average outcome when you face with uncertainties. But if any of the assumptions considered in expected value calculation is unreliable, then expected value calculated cannot be trusted. If any of the weight or the probabilities that you have chosen is unreliable, then obviously expected value is also going to be unreliable. And these are the uses of probabilities in budgeting. So why or how we can use probabilities in budgeting? We can use probabilities in revenue and expense forecasting by looking at the historical data and identifying the trends and pattern what was happening in the past. You can decide what will be the revenue or expense in the future. You can do a risk assessment by considering different economic situations, for example, economic downturns, changes in the market conditions. Based on that, you can assess the risk of the business and you can make a decision out of it. You can do a scenario analysis, best case, worst case, and most likely case scenario analysis. You will be able to do this if you know the probabilities of each of these cases can happen. And cash flow management that we have seen in the previous slide, how we can estimate our cash flow that may incur in future. Okay, for all this you can use probabilities, and that's the end of this chapter. And thanks a lot for watching this presentation. Thank you for being with me. Have a great day. Thank you.